questions can bivariate regressions help you to answer? Here, the process of conducting a bivariate regressions analysis. So the model on the slide is the procedure that we're going through. The first step is plotting the diagram. So a diagram or a scattergram is a plot of values of two variables for all the cases or the observations that we have collected. We will have the dependent variable on the vertical axis and independent variable on the horizontal axis. So this model is useful for determining the form of relationship between the variables. It will help to signal to the researcher the patterns of the data, and it helps to possible the problems that may occur because any unusual combinations of two variables can be easily identified. So for example, if the researcher wants to explain the attitude toward the city of residence in terms of duration of residence, like the example in the table 17.1, we have this scatter plot over here. So as one variable increases, so does the other. So the relationship between x and y is linear and could be well described by a straight line, but several straight lines can possibly drawn through the data. So how should the straight line be fitted to the best describe the data? Then the most commonly used technique for fitting a straight line to the scattergram is a least square procedure technique, which is you can see on the slide. This technique determining the best fitting line, which is also called the regression line. So the distance of all the points from a line are square, and then they are added up together. So we have the number called the sum of squares errors, or another name is the total error. So in fitting the line, the least squares procedures minimize the sum of square errors. The scatter diagram indicates whether there is a relationship between y and x, can be modeled as a straight line, and consequently, whether a bivariate regression model is appropriate or not. We move to step 2, which is formulate the bivariate regression model. So in the bivariate regression model, the general form of a straight line is y equal beta 0 plus beta 1 multiplied by x. This is the model of deterministic relationship model, where y is the dependent variable, x is the independent variable, beta 0 is the intercept, and beta 1 is the slope. However, in reality, you know that there is a few relationships are deterministic. So the regression procedures need to add an error term, which is EI. EI is the error term associated with I observation. Next is step 3, estimate the parameters. So in most cases, the slope and the intercept are known and are estimated from the sample observation using the equation over here, yi hat equal a plus b xi. So this is the manual technique, but more practically, I think we can run SPSS to have these two numbers available on the screen. Step 2 is estimate standardized regression coefficient. So standardization is the process when the raw data is transformed into new variables that have a mean of 0 and a variation of 1, like what we have learned in chapter 14. But when the data are standardized, the intercept assume a value of 0, and a term of beta coefficients or beta weight is used to denote the standardized regression coefficient. Step 5 is test for significance. So we have two hypotheses needs to be tested over here on the slide, H0 and H1. So the null hypothesis is where there is no linear relationship between x and y, and the alternative one is that there is a relationship, positive or negative, between x and y. So typically a two-tailed test is used and a t-statistics with a degree of freedom equals to the number of observation minus 2, where the t equals to b divided by SEB. Step 6 is about determining the strength and the significance of association. So the strength of association is measured by the coefficients of determination, R squared. This is the square of the simple correlation coefficients. It can be obtained by correlating the two variables, and this value lies between 0 and 1. It signifies the proportion of total variance in y is accounted by the variation in x. SSY, in this case, may be decomposed into the variation accorded by the regression line and the error or the residual variation. So the formula is SSY equal SSREC plus SSRES. And the strength of association may be calculated as the formula below. So finally, we will check the prediction accuracy. So to estimate the accuracy of predicted value, it is suggested that you can calculate the standard of error, in short, it is SEE. So this statistic is a standard deviation of the actual y value. We have two formulas over here. So SEE can be interpreted as a kind of average residuals from the regression equation. So there are two cases to predict. The first one is you predict the mean value of y for all the cases when given a value of x. So in this situation, standard error equal SEE over this least square of n. And the other case is you want to predict the value of y in a single case. The standard error equal SEE. SEE is different in the two situations, although in both situations it is a function of SEE. So in this slide, we have the regression model's assumptions. So these are 5 assumptions that the book have mentioned for us. You can see it on the slide. The next thing is the multiple regression. So it is a statistical technique that will simultaneously develop a mathematical relationship between two or more independent variables and one interval scale dependent variable. So the questions to answer is it can answer the question raised by the context of bivariate regression, but like the question, can variation in the market shares be counted by the size of sales force, advertising expenditure, and sales promotion budgets? And additional questions raised by multiple regression, like the second question, how much of variation in scale may be explained by advertising expenditure, price, and the level of distribution? We go to analyze regression and then linear. And then we moved attitude to the dependent box and duration into the independent variable box. So we click enter in the method box, and then we click on the statistics, check the estimates, and then check the model fit, click continue, and then we move to the plots. In the plot section, we move the zres ID into the Y box and zp red into the X box. And then we check the histogram and normal probability plots. And then click continue and click OK. So this is the results that we have collected. As you can see, for the chart, this is the scatter plot charts, and this line over here is called the regression line. For interpret the results, so the intercept, we have the intercept equals 1.079, and the slope is 0.59. So according to this result, we have the equation that the y hat, which is called the attitude, equal 1.079 plus 0.59 multiplied by duration of residence. That is the equation. And the standard error is 0.07, and the value of t statistics over here is 8.414, with the degree of freedom is 10. And from the charts, we can from the table in the book, we can see that with the alpha of 0.05 and the degree of freedom is 10, we have the critical value is 2.228 for a two-tailed test. So it's easily seen that this t is larger than the critical value that I have mentioned. So we reject this, the null hypothesis is rejected, which means that there is a significant linear relationship between attitude toward the city and the duration of residence in the city. And also the slope that we have mentioned is positive, so the relationship between these two variables is also positive. And so we can conclude that the people that have lived in the city for a longer time will have more positive attitude toward the city. And that is the interpretation for this SPSS statistics.